Okay, looks like I'm live. Hello and greetings to you, viewer from across the tubes. I am Gnarly Quack, although my friends and enemies call me Carl, and I'm back at it. Gonna be kind of just slamming my head against the desk a little bit, messing around with Rust, and hopefully solving some advent of code problems. We'll see though. It's already late, and I have to say I'm actually kind of tired, so this might be a mistake. But we will attempt to pick up where we left off yesterday with part two of day two. And I think one thing I'm learning, or maybe more hoping than learning about the advent of code, is that the day just because they're in an early day, I think doesn't mean the problems are any easier. Hopefully, than if you get to the end day, but we'll see. I've never gotten past day 8 in the 2015 advent of code, but we'll press on. So basically left off stuck here at part 2 of day 2. I guess I already said that, and I guess I should probably get into my code. And we have a big mess in here right now. So when I go into Rust in 2024, let's get my other terminal in there. And we'll stay here. I think we are actually running and compiling. We even have passing tests. Oh, which is taking forever. Oh, and our tests are failing. Okay, well, that's fine. So let's see here. And actually, I'm going to bring the problem up over to my little side window here. So, oops. Did not update my plugins. What few I have installed. So we're doing the problem where we did part 1. So we have these reports from the nuclear reactor, the fusion/fission reactor, and what we are looking for is basically a series of increasing or decreasing reports. Any number of numbers where these differences between the two are, so like the difference between all of these right now is 2. So the magnitude of these differences has to be between 1 and 3, and they all have to be the same sign. So either all increasing or decreasing. So after sorting out some stupid logic errors that I had yesterday, we got part 1 done. And now they threw a little bit of a wrench into the works where the problem dampener allows us to take out one bad node. And if taking out that node makes the rest of the report good, then the report is still safe. So after thinking about this, I guess it's a little bit of like a simplified sort of, well, I don't know, graph problem is what I want to call it. But I was kind of going about it all wrong. So what we're saying is, so like right here, if we bump this to 6, right, this goes to a 5 magnitude, and this goes to a -1. But if, and actually, this would still be invalid because even if we knock this node out, the difference between these two is 4, which is still bad. But let's say this was like 3. So this magnitude is 3, which is good, but then this one is -1, which is bad. But again, if we take this out, then this is 2, right? The difference between 3 and 5 here is 2, and we're all good. So, but another scenario we could have is we could have this, right? Where the magnitude here is -1, but here it's 3. And if we knock out this first one, this makes the report good. So, and this is at least one of the problems I had last night was I was sort of using the first two comparisons to determine what our magnitude should look like. But if it turns out this first one is bad, right? This not magnitude, but this ordering or sign doesn't matter, right? Because we're going to throw this out, and then everything else goes up. And then, so there are cases where with this bad transition, right? In this case, we want to throw out the node before it. But in the previous case, right? Well, if we leave it like, what do we say? Like, right? This is a bad node here. So if we throw out the node, or a bad transition, if we throw out the node after it, then we're in good shape. So it's not necessarily consistent whether a bad transition indicates the node before it or the node after it is the problem. And I think that's basically it. I mean, I can walk through some more cases here. So let's see. Like if we took this to 4, right, that's 2, that's 1, and actually we could even, right, take this to 5, so that's still good, but this is bad here. But if we knock out, like this is the bad transition, if we knock out any one of either of these 5s, the rest of the report becomes good. But if we like set this back to 4, but we set this to, actually we probably have to set this to like 6, but then if we set that to like 2, right, that's it looks something like this, but again, if we take out the 2, we're good. So, it's kind of straightforward, I guess, what we have to do, which doesn't mean to say it won't be some persnickety logic. But in general, I guess, what sort of makes this a little trickier is this first and last case are a little bit special case. So let's go to the scenario here where this is like a 5, right? So that goes to -1, that goes to 2, and then let's just put this back to something that works, right? That's 1 and 2. So in this case, if we knock out this first one, we disregard this altogether, and our starting point is going to be the second transition. But let's say it's something like yeah, that works, right? That's 3 and 0, or whatever we can, whatever that is. So in this case, if we knock this out, we want to look ahead at the number after it and see what that transition looks like. And we can tell if that's legitimate, because if we combine actually, like if we sum up these two, right, we're going to get a difference of 3, and that's legit. So from here, we have one case where we throw out the one behind it. If that's the first one, we disregard it, go on to the next one. Or I think we have the more general case where we throw out the one behind it. Or I'm sorry, not throw out the one behind it, throw out the one in front of it. And then we combine this transition with the transition of the node before it and see if we get a valid transition. So it's a little bit of like a look ahead. And then we have a case where it's going to be a look behind. So let's see here. Let's make that right. If we do 5, 8, right? So that's 3. That's -2, and yeah. So in this case, this is good, but this is bad. So now what we want to do is we want to throw out the one behind it and combine this transition with the one behind it, right? And that gives us 1, and that's okay. So the rest of the report comes okay. And then I guess at the end here, so let's put that right. I think the only other potential special case is uh, 5, I don't know, 6, and then let's say this is, I don't know, 12, right? Whatever it is. So in this case, we throw out the very last one, and then we just drop this transition, and the rest of the report looks okay. So if we're at the beginning, we throw out the one behind us, and we ignore that transition. If we're at the end, we can throw out the one ahead of us, ignore that transition. Otherwise, we throw out the node behind us and combine the transition to that node with the next transition, right? So for here, we throw out this node and combine these two transitions, or we can throw out this node and combine these two transitions. And if we end up in a good transition, we can keep going until we either hit the end or another bad transition. So that's the gist of what we have to do. So now that I've figured out the solution, it's just implementing it. So day 2, what is, I don't even know what's failing here. I guess it would help, we could open the code. So on 131. So our first day is still working. Our part one is still working. So we've got 3 things we want to look at. We have our previous, we have our current, and I guess we can have our next. I don't know, what am I overwriting here? Oh, there it is. That was a slow one. That was a slow creeper. And then we have, I guess, next. So we may not have a previous. I think current we should always have. And next doesn't really matter. Now I'm not sure what Rust is going to let us do here in terms of initialization. But I guess we'll cross that bridge when we come to it. And then I guess we also want what is our verbiage here? Let's actually switch over to the big one. There really is no nomenclature of choice, I guess. So I think we want to have maybe like previous difference and the next difference. And then I think probably what we're going to want to have is was bad. So, right, we get one bad. So if we are bad, or I guess we could say unsafe. So if we are unsafe and we toss out one of these nodes, that makes us safe. We flip unsafe back to false, and we flip was unsafe back to true, or up to true. And if we're unsafe again, then we know we're no good. Okay. So now we want to get our iterator. And actually, we'll start there, I guess. Let's bump these down here because I think what I want to do is, presumably we need to have at least two inputs. So let's parse our first int. I need to make that mutable. And now, because we're not actually checking our iterator, I'm actually going to put in, I think, an assertion down here. So first we eat up all the white space. Then we do a little bit of nonsense here so we can cast or convert our character into an integer. But what I want to make sure, because we're not doing any check before we get in here, is right, we expect to get, it's okay to gobble up some white space, but we expect to get at least one number. So I think I'm going to do, just throw an assertion that I know is none is an option, so, but I'm wondering if there's like a like is some. Yeah. So we want to make sure we have a number. We parse that number out until we have no more digits, and at that point, we're good. So we want to get the current and the next. And then start parsing our difference. So, and I guess we can maybe just set that up right away. At some point, we're going to want to get into this loop. So, in this case, I guess we'll set this to previous difference. And I'm wondering, you know what, let's just set it to let's do that. And I'm trying to think of how we want to handle the special case. So I guess if the only way I guess we could be bad in this case is if our magnitude is greater than 3. Or if we're equal. So if and I'm actually not sure what we can all do with a match. So expression, can we do, well, let's just try it. So, actually, I guess we have this here. Like what I want to do, and I don't think I can do it, is something like this is what I don't think I can do. So, but we might as well try it. um, so any sort of example operator. I guess maybe something like this, huh? Of course, it's possible I'm just trying to be too clever as well. So, and I'm almost thinking about bundling this up too. So let's just do that. So we want, I don't know, order, that's going to be an ordering, and we want, I guess amount, and that'll be an I32. So I have it enclosed, so we're not going to do that. So we'll do, I don't know, left, and that'll return a transition, and we'll do is going to be so order is going to be and amount is going to be, actually it's going to be so I'm just thinking, right? So we have the way of determining equal two ways. Our amount will be 0, or ordering will be, I think, equal. But so if So, I think in this case, we want to continue. So if we don't have another number to peak, right? So this means we have got a bad change. What happened to, get change? Otherwise, we want to set and right, we just want to toss that. We just want to toss that first one because this is our first it's the first one. So let's see here. And in fact, let's make this another helper function. I guess in one case I called it change, and in the other I call it transition. So this is going to be just what I had up here. So in this case, it's going to be that's what our valid change is going to look like. So and if this is not valid, then and actually we can continue because we're parsing all these lines. So now if we've gotten to this part, we know we have a good difference. So we will have calculated difference between current and next at this point. So I guess we want and I guess it would make sense then to call this next diff. I suppose that would help things out. Okay, then and then let's see. Um, so I guess at this point, and then we want uh, actually, if this is not, then we can continue. Otherwise, we want was bad equal to true, right? Because we've already burnt up our um our out. So I'm just thinking because right, we've got kind of two comparison cases. We've got the magnitude of the of right. We've got the magnitude of this change, which is dependent only on the change itself. But then we've got whether the sign of the change, right, of this change matches the sign of the previous change. So we've got two changes basically. So I almost kind of feel like maybe we'll call it, I don't know. Uh, is valid advance. So we want so we want guess my terminal's shrunk down a little bit. We want is a valid change the next change, and ugh, okay, so Okay, so if then we will set actually I guess I should probably try and settle on some common terminology. Okay, so if it's a val in advance, we I guess we could actually do this here. Uh fact, yes, let's do that there. Let's set I guess it doesn't really matter if we instantiate that. Okay. So if it's valid, we just no, we don't continue. Oh yeah, we do continue because we're in yet another loop here. So we are not valid at this point. So do I still have that buffer open? Boy, I hope I unmuted. Okay, I guess I did unmute after my sneeze. So let's say we're sitting I guess it doesn't matter. We're here. And we have a bad change. Actually, I think I'm doing this completely wrong. Nope, I'm not. Okay. So let's make this like an invalid case. So that's valid here, right? So in this case, we're invalid because of right. So we calculated this change and compared it to last change. So if we toss this out, and actually this probably isn't the interesting case. This may be the interesting case. So that's valid. That's not, right? So in this case, we want to toss the 7 and then combine with that. I guess that's fine. I guess that's fine. Because I thought we actually needed to check that one, but I guess this is fine. So what we want to do here is Okay, let's try tossing out the previous node. And actually, I'm going to bump that out. So in this case, say we're sitting here, we want to toss that out. So we want to combine so we want to combine, I guess, the previous change and the next change, right? Then, and actually, what we can do here, we can early exit. If we were already bad, we can continue. So if we combine the change, then I may not strictly need this is bad. Oh, that's right. I changed my. But I may not need that isn't safe, but I still want to be able to get the correct answer back for part one. So we probably need to set that. So what we'll do here is so if you can combine the change, then we said wasn't safe, and I guess actually this isn't a continue. This is a break. So, and I think this is going to pretty much look something like this. Um, so let's see what that looks like. So in this case, um, well, actually, this is not, so let's go. And so if we, let's make that 5. So that puts us in the same situation, right? But tossing out the previous one, tossing out the next one is going to work. So, um, we kind of want to do this. I guess we can shadow that. Actually, we don't want to set previous. We want current to be next. We want the previous change to be the next change. And we want to parse another int. And we want to get that change. I guess that'll look the same. I guess this will kind of look the same. In that case, we're done with that, I think. So let's clean some of this up. And I guess if we make it this far, we might be good. Now, we still have to do this. So what kind of stinks about this is we would just want to like it'd be nice to just be able to add the amounts, right? So if it's negative, we can offset. And now I'm thinking actually did the logic on this wrong. So we have a problem here. So what was my example before? So this is an invalid advance because the sign is different. So if we throw out the 6, right, okay, so that becomes, but let's say, that's valid, that's not. So I guess we're saying we already know this is valid behind us, right? So if we combine, so what are we passing in here? So next change is out. Yeah. So but I kind of feel like all right, so you know what? We're just gonna make this an I-32. So that's just gonna be I guess this is not a struct anymore, so and let's not do bitwise operation. Okay. I guess since we're tossing out zero changes, this could turn into okay. So but we also want to like set that. And actually I think that's what I'm saying, the logic um the logic is going to be different if we're throwing out a head. So what was my example here? I guess here. Uh, Actually, let's make that. And this is, but this could be, say, 3, right? So that's -6. So in that case, the total is -2. So we do actually need to compare it to that. Or do we? I don't think we do actually. But instead of calling the combined changes, I think I'm going to call that toss back. Actually, let's call it toss previous. And I thought actually this is going to be so I think in this case we want is valid change. So I don't think I'm using this check level anymore, right? Okay, so let's go. Um, I almost wonder if we should, instead of making this a bool, do like and we'll do the same thing here. Okay, so there's like no way this is going to compile. And we still, oh, that's right, we're just returning that. So I guess we're gonna let next change equal combined. All right. I am about as skeptical can be. Oops. That was skillful of me. For some definition of the word. All right. Well, I have so many errors. I can't even scroll up for them all. Oh, I think I. Oh, that's option. I may never get used to. To that. So 131. Oh, um, so what's the problem here? Two. Let's just. We're not using ordering anymore. Oh, really? We're not using previous? I feel like that's so left equals right failed. So where did that fail? We're no longer passing part one. All right. Okay, so this may have to. This would be nice for. Be nice to have a debugger. So I can just use GDB. That was remarkably unhelpful. So is cargo have because right, the thing is I don't necessarily know where my executable is. What is going on here? Okay, well, I may just have to printf debug this, which is annoying. So let's see here. So what even is my example here? So okay, all right. So move this down here. Oh, well, I never, oh no, I returned it. Actually, we want that to be, all right. So 7, 6 changes 1. 6 and 4 changes 2. And actually, let's print out, it'd be nice to, uh, I don't know, it's just, okay. So changes 1, that's good. 6 and 4, changes 2, 4 and 2. Well, I guess it doesn't really matter, but so that was safe and it was perfect. So 1, this is really 1, 2. So this should be okay, right? No. Uh, So current is, and actually I should have fixed this. So why, yeah, this should be, okay. That's okay. 2 to 7 changes 5. But we said it was safe. Why did we say it was safe? I guess because we only broke out of one level of the loop. Do I even want to know how much time I spent on this? Probably not. uh, right. So let's see here. So was it safe? It was neither safe nor perfect. So 9. So 9, uh, we couldn't recover that one. So let's see. So 1 and 3, the change was 2. So then 3 to 2, the change is -1, so it was invalid. But if we tossed out 3, so 2 and 4 is 2. So it was safe, but it was perfect. So 8, 6, 4, 4, 1. So 8 and 6 is -2, -2. So why did we think that was invalid? That should have been valid. So I guess we're here. So is valid advance. So we tossed. So where do we print the change here? So changes 2, 2 and then 3. Oh, wait, 1. Why did that panic? I don't remember any more. Changes -2, so 7, 6, so -2 and -1. Okay, so 1 and 3 changes 2. So this changes -1 were invalid, so 2 and 4. So previous change should be 1. Next change is 2, that's right. Previous change was 2, okay, so -2. So we tossed the 0. So now current is 4. Uh, so this is going to be so 8. Okay, so let's see here. So what were, oops. So let's do 3, 4, 5, 9, 3. So that's not valid. But 6, so that's 1. So let's do so we want to do So that's bad. So let's do. So right that we throw that run out, right? Actually, I should really probably just make these all their own tests. Um, and I don't know. Let's just run this for now. We're gonna mark these tests. My examples failed. So let's see. $231. That could be true for all I know. So we only had one here fail. So let's see. That should be safe. Right, if we toss the 9, we're good. If we toss the 6, we're good. If we toss the 7, we're good. So let's see here. Current is 5. That seems wrong to me that it couldn't recover. Okay, so we couldn't. Okay, so that was what, the first one? Okay, so 3. So here if we toss the 9, oh, tossing the 6 shouldn't work. It's 1. That is wrong. This is valid, but not because. So toss previous. So we're passing in. Tossing. So I think this is just strong here. Okay, so let's see. 6. Actually, this is still not working. Um, so why did I not? So this is invalid. But tossing the 4 does not fix it. Um, So let's see here. And like there is no transition there. Well, boy, this one's really kicking my butt. So I'm just trying to think. Maybe the best way to do this is actually to um, build the list, but so like we can maybe make this a list. So the last element never has a transition, right? Um, like if we assume these are our values and these are transitions, so we could sort of remap this to a list of, where this is just an index of almost sort of nodes to transitions. So what was another case we had? We had one where we want to toss the 4, right? So even if we did um, so that transition is 3. That's -1. 2, and 2. So if we toss the 1, I guess what we would do is, right, let's say we toss 1 and we roll up its change, I suppose. Okay, so now let's see. So we had one where we want to toss that one. Then we toss this one. So let's just say this is 2. The transition of 2 takes us to 3. Transition of -1 takes us to 2. And a transition of 5 takes us to 7. But we probably want to make, and then a transition of 3 takes us to, right, so 2 takes us to 3, then -1. So again, here we fix this by throwing out, oh, I did literally the same thing here. So this is, so 0 to 2 takes us to 3. So 3 plus 5 takes us to 8. 8 minus 2. So if we were looking at this, right, although this doesn't need to be, um, so this is easy to throw out because that's already invalid, but if that's a 3, right, we'd be inclined to throw this out. But I guess throwing that 5 out would actually work. But it wouldn't work here. Right. 2 is 3, right? 2, then 3 takes us to 6, and -2. 0. That's 3. Oh, I was saying, I guess that does give us the right answer. Uh, so the answer here is actually throwing out this 5 would fix it. I guess in this case throwing out either one would fix it. So what was this example that wouldn't work? So if we so like if we say we toss that out, what about the case where so basically we're saying, right, this is 2 goes to 3, since I am having a hard time just keeping this straight. 3 goes to 4, right? This is 4 goes to 5. 2, 3, 4. Uh, so 4, so this is like a special case. Right, because we're saying, right, we've kind of been saying the one we toss out, we need to apply it to the previous one to know what the difference is between the next one. So there is no previous one here. I guess this one, there is no next one. Um, so I guess it's easy to sit here and look to see which one we need to toss out. But right, like in this case, or even in this case, uh, when we look at the first two ones, we don't know what's right. We have to kind of look at the whole list to see what are we doing. And if we can't make a decision, we're probably invalid because we have more than one invalid or more than one unsafe transition. So it's almost like we need to build the list. Like we need to go through and make a decision about what the right answer is, assuming we can come up with one, and then we need to figure out which one to toss out. Or if we really just brute forced it, we could right, we don't need to make a decision. We could just start tossing one out. Let's see, how long have I been going? 2 hours already, and I've made essentially no progress on this problem. That is motivating. Ugh. I may have to take a little break. I'm not sure. Hey Eldon, how you doing? I am very much on the struggle bus with part two of day two. I don't know. Have you been doing the Advent of Code this year? I've spent like 2 hours on it tonight, and I think I spent at least an hour on it last night, and I cannot get past part two. Uh, so basically, the problem statement is we have these lists of numbers. 2024, day two, part two. So we have these lists of numbers, and they either have to all increase or decrease, and the amount of change can only be between 1 and 3. So this one was fairly straightforward, but the part two of it, it gives you the same list, and you're allowed to throw out one of the numbers if throwing out that number makes all the other numbers satisfy the conditions. Oh, okay. Well, you're way ahead of me. And I'm just learning Rust too, but I've been too stuck on the actual problem to um do too much rusting tonight. I'm hoping the days aren't indicative of how hard the problems are. Because like if this is a if they're supposed to get harder as the days go on, then I should probably just give up now because this is day two and it's really stumped me. So I was just kind of sitting here talking to myself, trying to work through it. So I'm kind of at a point where I feel like I need to just build these lists of all the transitions. Sorry, if I take these numbers, I mean these are the indexes I have here, but I just convert that into a list of transitions. And I was just saying it's easy to look at and see which one we need to toss out. But right, if we start walking through the list and we look at these first two, we don't know which one is right because we have to kind of look at the rest of the list and see what the rest of the list ends up doing because this could end up being, like 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 that. In this case, we want to throw out the one, but in this case, we want to throw out the -2. So I'm like, well, do we just brute force it then? We just start tossing out nodes? Yeah. Yeah, this is kind of my first time really doing much coding in Rust. Yeah, well, part one, I didn't even build a list. In fact, actually, I didn't even commit part one. So I've kind of torn all that code up. But basically, I just did a I guess you could just pick a number to skip, huh? So like if you go through and one doesn't work, you could go through and just try and skip that one, I suppose. Let's see if I can even just do my I thought I was pretty close, but then there's always some edge case that trips you up. uh, so I'm just kind of sitting here wallowing for a minute, if you don't mind. I'm trying to think if I can even just build up my simple solution that I had before. So, I may just do, I may just, I don't know. Do you know, like in C, which is, I'm more familiar with like C and C++, you can do like an if zero, like a define statement to just comment out code. Do you know if there's like anything similar in Rust as opposed to just doing that? I guess I'll just do that for now. Because usually if you do something right like this, right? And then you put a nested in there. I don't know, maybe Rust is smart enough to know how to nest comments, but right, if you usually comments like this don't nest, so if you have this somewhere in all the code you've commented out, it ends your comment. Yeah. Well, I do still have part one passing. Uh, so I have a test that I started adding myself. So, and actually, the part two test is the example they gave. I have passing, but I've changed the code so much it's not simple anymore. Um, so I guess I kind of got to this point. So I may not even need to. Actually, I may need to make those mutable. So if what did I do here? Then we can just break, right? So that's if our magnitude is bad. Um, so then we need to do me. Well, I was where's my notes? I kind of wrote over all my notes too. Uh, I thought we could just look at these transitions and like so if we have so what I was doing was I was calculating the initial transition and then I was pulling the next number and calculating that transition and comparing it. So first there's a magnitude check, right? So if it's less than, if it's 0 greater than 3, um, it's invalid. And then I was kind of treating that as like, so there's a transition. So like in this case, this -2 here is a transition from 6 to 4. So I was saying, well, this is a bad transition. So if we throw out, well, the first one's a special case because we can just throw out the first one and then ignore this transition. But there could be, like in this case, we wanted to throw out, oh, the transition would happen here, right? Because in this case, the magnitude is okay, but in this case, it was a positive transition, and this was a negative. So that was the second thing I was doing, comparing the sign change. And then I was, right, there are cases where whether you throw out this one or this one, that could make the list fix. So basically, I was trying to, like, if you toss the previous node, do we then end up with a valid transition? Or if we toss the next node, does that make, right, then we combine it with this transition. Does that equal another one? But then I got to a point where that logic kind of broke down. Because actually it was right here, right? So this transition is -2. That's actually a valid transition. But this transition is 1. But the answer here, which this is an invalid transition, but only because we assume this one is valid. So So the answer is to throw out not this one, but the one even back. So that's kind of where I got when I realized what I was doing um, wasn't really going to work. I don't know if that made sense what I described, but that's what I was doing. So, and that's kind of right where you came in. So now I'm not sure. Now I'm not sure what to do other than maybe go back to my simple solution for part one and then just like brute force it, like you mentioned. Because I was thinking about, well, I can maybe build a list of all the transition values and then kind of go through and try and figure out which one to throw out. But that seems like I would have to scan the list, try and make some decision about what direction it should be moving, and then go find the one that's bad, assuming there is only one bad one to throw out. So that's kind of where I'm at now, just trying to figure out what to do next. Oh, that's my parse int. So I was just going to comment all this out and go back to my solution that only solved part one, and then look into brute forcing, like you suggested or mentioned. Oh, really? So I've been curious if the outputs are custom for everybody, and I guess they must be. Which makes me wonder if I shouldn't be committing them to the Git repo. I guess it doesn't really matter. It's not like it's private information or anything, but I wasn't sure if everybody's inputs were custom generated or not. But it was kind of to the point yesterday. Um, if you put in like two or three wrong guesses, at some point the website is like, give it about at least 5 minutes before you try again. Like it's basically saying, step away from the keyboard for a little while. Oh, okay. Well, I actually didn't realize that. I guess that discourages people from signing up, so that's a good point. So I suppose I should remove them. Well, it's too late; they're on the internet now. But I guess I should remove them from my repo. Okay. Oh, that makes sense. Uh, Actually, I don't think I've even pushed up. So the only thing I think I have up on my GitHub repo are the first 8 problems from 2015. So I haven't put a lot up there. Yeah, I haven't pushed these up yet. So I can take out the 2024 inputs already. You know what? I think my water glass is empty. I think I'm actually gonna step away for about 2 or 3 minutes and refill my water glass. Yeah, I didn't know. I actually didn't know they requested people not to, so I have no problem not committing them. I just didn't realize it was I actually didn't even realize they were different for people. I just assumed they were all the same, but um I actually didn't realize they requested that. Um, but yeah, I'm gonna take a break for like 2 minutes, maybe three, just to refill my water. Um, so yeah, I'll be back in just a couple of minutes if you end up hanging out. Uh, okay, back in a minute. Okay, I think I'm back. Looks like it. Oh, okay. Well, I'm definitely not competing. I'm still on day two. Yep. Okay. Well, guilty. All right. Well, I won't do it right now, but I'll off stream. I'll go remove my inputs for the what I do have posted. uh, so what we'll do. So right, if we break here, we don't have a valid input. So I guess and then while we have more characters to peek, right, previous change equals the change. And then what I say equals. So I guess um, we'll set that to false and we'll break. Otherwise, I guess we should be okay. So I think that should get us back to let's see. A solution for part one. And we'll just comment those out. What? Where'd my percent go? Oh, wait, I got rid of my iterator. What happened to my iterator? Not found in, oh, is valid. Well, oh, because I'm not actually changing that. All right. Well, that's just a warning. I guess I don't need to, I can just shadow it, I suppose, but I don't know. I don't want to do that because I want to. And all right, so I got part one passing. Um, so I feel like looping through this again would be. Don't really have a clear idea of how to do that. Or a good way to do that, I should say. Um, okay. So I will take your advice and save that. Because I think what I am going to do is maybe build a list. So, all right. Um, so I guess what I can do in this case is go through the line and populate the list. So let's just do that. Actually, I guess so. So that I think should populate my list. Although I can never decide on nomenclature apparently. Actually, let's get an iterator out of this. Actually, we don't, I guess we could shadow that other iterator equals and so this is where I would probably just want to index into it, but I guess you're not supposed to do that with Rust. But I guess what I want to do is I want to pick off the first change because I need to get opinion about whether the change should be increasing or decreasing. And then start checking the magnitudes of the changes. So, which I guess what I could do is, and actually, I don't even know, do Rust vectors have that? Like I have here? Okay, cool. Um, so I guess I could, I want my, and I guess we can just break out of there. Otherwise, what was my other test? Oh yeah, all right. Actually, why? How is that working? It's not working. Okay. I read this one. I didn't read that one. Oh, that's just a warning. Oh, I forgot to make that mutable. So, oh, it's barking at me twice. So, all right. So I'm still failing at part two. So actually, I don't think this is going to work very well either. So what was I saying? I was saying I think so if I make a list of changes like this, um, the very first one and the very last one are a special case. I can just ditch them. But if I take one out in the middle, I think I've got to add the change to the previous change to see if that results in a valid change. Right. So if I knock out the one at the end, there is no next change. So the next change is just going to be whatever the previous one is. But like for here, we've gone down two and then back up one. So that's a net change of one, right? Yeah. So to get right, so we're kind of right. This would result in a list of you know yeah. So which maybe I need to enumerate here. And I guess I could actually just combine these conditions. Um, Kurziv's gonna yell at me about not using I. Yeah, true, true. Uh, but won't let me do that anyway. So, but how would I do that in Rust? Because there isn't really like a for loop like C. Would I have to build a range off the size of the changes? Like like something like that? And then like I guess I can try that. I guess I need to bring in slice. Oh, I don't even need range. That's uh that's too much Python. Or that's me wanting to code Python now. um, oops. So and I guess we can check. I keep and maybe it's worth not actually sure that's less typing, but there you go. So what I guess maybe I'll do of course um So I guess what we want to do is and we want to break. So if we are already unsafe, we're not safe, and we're done. Otherwise, we want to toggle on that we are unsafe. And then we can either toss that out or here we're accounting for that change, which I think whether I pull it back or push it forward shouldn't matter. Um, and then we'll go on to the next thing. So now down here, so this is actually going to be safe, but perfect plus equals, well, I don't know. Okay, so what's wrong with that? Uh, but I gotta put it there, and I guess I need to dereference that. Oh, I guess. And now I can remove that. Wait a minute. I feel like I should be changing that there. Oh, this is down here. Okay. All right, well, my unit tests are passing. And we panicked. Well, that's demoralizing. I felt like that was going to be a big moment, and it wasn't. Um, so where are we calling parse int? That's a little bizarre that that's panicking. Um, I wonder if that's because what happens if we just take that out? All right. uh, yeah. I was feeling lucky about it. Was also, I'm pretty sure, a different answer than the other like 4 or 5 or 6 I put in there. So yeah, it's kind of telling me like you're feeling hard there, guy. I'm kind of wondering why this is panicking. I wonder if it's just like this new line at the end of the file. I don't know. I don't know. Uh, well, maybe my assumption about pushing forward is wrong. So we said, so in this case, right, we're saying this -1 is bad, which is here, and I'm saying, well, we can just add it. Actually, yeah, maybe it's that assumption. Maybe I have to push it back and recheck it. But then I kind of don't want to advance. So let's see here. Okay, I think I'm going to pull that out. Actually, I guess I didn't need to go all the way down there. Um, so if the change is between 0 and, right, greater than 0, less than 4, um, apparently I defined a very similar function elsewhere. And I guess I want this to be mutable now. So now we need to check this again. Or what am I saying? Is safe. I guess we can just break at that point. Because we know that will not have fixed it. So has it been 5 minutes? Now although my tests aren't even passing. So I think now I'm failing part one. Yeah. So let me do this. Let's make sure I did that right. Apparently not. Oh, that's why. Okay. uh, so what did I do? I said change. I probably should have just commented that out, but so if we're still not positive, then I think we said is safe is false and we broke. I think it's going to say, kind of make that mutable. Okay. Well, I got a different answer yet again. Oh, this is brutal. This is brutal. Yeah. I feel like at this point I should just every 5 minutes I should just brute force. I'm like it's got to be somewhere between 620 and 600, around 650, right? So every 5 minutes I'll just put in another answer and see if I get it. It's a little bit annoying that it's not telling me, like it doesn't tell me anymore if I'm too low or too high. Yeah, true. Yep. That's true. I could just be not even close to getting it right and it's actually like 800. Yeah. Oh, telling you whether you're too high or too low. That's a good point. That's a good point. Yeah. Yeah, it was kind of nice. I mean, I guess if we're actually doing it, it's not a huge amount of information, but I didn't even think of just like not even solving the problem and just writing a brute force, binary guessing algorithm. Well, I'm not sure. I've been going at this for 3 hours now. Time even is it? Oh wow. I guess I got that's right. I got a late start because it's after 1 in the morning for me. I may have to stew over this some more, which is kind of a bummer. I was feeling motivated. I was going to get this solved. I did not think this was going to be nearly this hard, but there you go. I know. I'm tempted. I'm a little bit tempted just to do like a search for somebody's 2024 GitHub repo, but I guess that'd be kind of like cheating. Yeah, I think I might call it there. Sure. If you want to drop it in, um, I haven't decided. I haven't actually decided if I'm going to go look at somebody's solution. But if you drop it in, I'll at least know how to get back to it. No, I'm kind of. I would like to just figure it out. Uh, so I mean, yeah, you're welcome to drop it. I don't know that I'm going to look at it, but I'm just kind of frustrated with it at this point. So, and right, it was a work day for me too, and I program for a living. So well, actually, I didn't do any coding today. I did, today I was stuck in code reviews for the entire day. Uh, Not really stuck, but I was doing code reviews all day and didn't actually write any code. So, but it was still a tiring day. So yeah, I think I'm gonna call it. I don't know. Um, I guess I may try and jump back on tomorrow and keep going it. I'm not sure yet, but I wasn't expecting this to be this hard of a problem. Okay, and hopefully no puzzle inputs. That's all right. I won't call you out if they're up there. Anyway, well then, appreciate you stopping in and chatting with me and for assist on the Rust questions. There's like two battles I'm fighting here: the puzzle itself, and then kind of figuring out how to code in Rust because this is like the first serious effort I've made to write anything in it. So okay, yeah. Usually it seems like part two is um kind of a similar enough, like the logic to get to it is close enough to part one. It's just like you need to tweak it a little bit. That I've kind of just been like adding the solution to that. Maybe that's the wrong way to do it, but of course I'm only on day two. Um, but then I figured I could start pulling stuff out like parse int. Like I'm using this function for day one. So it's like I guess if there's common stuff I need to start doing, assuming I ever get past day two, I can start pulling stuff out into libraries or modules, I guess. But anyway, that would require actually getting farther along in this. So anyway, I'm gonna call it there. Eldon, thanks for stopping in and hanging out and for the assist on the rest. So if I am gonna be back on tomorrow, I don't really have a schedule. I'll just jump on at some point. But 1. Oh, okay. Yeah, I figure I should, I'm probably supposed to be using iterators and, yeah, actually, I think mine won't panic. I'll just get zeros back. But yeah, I haven't really gotten into the flow too much yet of, like the maps and, collects and everything. But, although I was thinking I'd actually go in and, because this whole thing with, I was thinking about actually changing this from a string to just a slice of bytes. Because even though we're getting text inputs, I mean, it's going to be ASCII. So, and that might make some things nicer. Like, I could just do a length of this iterator instead of like peeking and seeing if I get something back. So, yeah, that's true. Yeah, that's a good point. I guess I could have bad input and I'm just getting zeros back when I shouldn't be, so who knows? It could be anything. It could be anything wrong. Anyway, all right. Well, again, thanks, Ellen, for stopping in. And yeah, guess I may try and come back on tomorrow. I guess I'll see how I'm feeling. But thanks for joining me. And until next time, I bid you peace. Cheers.